Hey guys, another very important question as far as your examinations are concerned, that is the 14th question. Okay, we are dealing with the concept of friction while reinforcing the concepts of the kinematics and the Newton's laws and the friction. So basically this chapter is on friction. So the 14th question says that a snooker ball of mass 0.4 kg is struck towards the cushion from 0.8 meter away with speed 3 meter per second. So I'm just having two diagrams side by side. So this is the diagram. This is for the kinematics thing, that the initial speed is 3 meter per second and the distance from the cushion is 0.8 meters. So I've taken this starting point as A, and let's say the cushion of that snooker table is at the point B. So this distance AB over here right now, that is going to be 0.8 meters. Okay, now coming back to this diagram where we shall be showing the force, is the force diagram. Now once you have pushed, you have struck this snooker ball, so then there will be no more driving force in it. There would be just one force acting on it. That would be like if this ball is moving towards the cushion over here, then there would be the backward force, the frictional force. Okay, that is because of the roughness of this surface and of this R over here. Okay, so let us calculate the frictional force. We have been given the coefficient of friction is 0.3. okay, so the coefficient of friction is given as 0.3. so let me calculate this frictional force. So that is mu r. This is 0.3 times 4, that is going to be 1.2 newtons. Now guys, please remember, now wherever this ball is going to move on this snooker table, the ball is the same, the table is the same, the coefficient of friction is unchanged, R is unchanged. So this frictional force is going to be the same, that is 1.2 Newton. If it is moving towards the cushion, it would be opposite to this direction. This would be away from the cushion, that would be acting against this direction. And suppose if the ball has struck this cushion and it has rebounded, then the frictional force would be acting opposite to that direction. But the point is that this will remain the same. Okay, now coming to the point, now he says the surface, this when the ball bounces from the cushion, its speed is reduced by 20%. Oh, so when it hits this cushion over here, the speed is reduced by 20%. Okay, find how far from the cushion it stops. So basically the ball will hit the cushion, it will rebound, and obviously there is no forward force on it. There is this 1.2 Newton frictional force, so this will have to stop eventually. Now let us find out using F equal to ma, that how much is the deceleration, so that we can find the speed while it is hitting that cushion. So just going to use the F equal to ma over here. Now there is no forward force, so let me write this as 0, and there is the backward force 1.2, the mass is 0.4, and we're going to calculate the acceleration. So this is F equal to ma. So the acceleration will remain, this deceleration will remain minus 3 meter per second. So wherever the ball goes, whatever its speed, with whatever speed you have hit it, its deceleration is going to be minus 3 meter per second square. Okay, now we know that, let's come on to this diagram. Now this is initial speed, this is the distance. We have to find the speed over here, that what is the speed through which it hits this cushion over here. Okay, we have the initial speed, the distance, we have got the acceleration. So let's use the equation 2as, that is equal to v square minus u square. So this is going to be 2 into minus 3 is minus 6 into s. Oh, s is 0.8 basically. This is 0.8, and we will find the speed. This is v square, and minus this is 9. Okay, so let us calculate this. This is going to be 9 minus 4.8. Yeah, this is 4.2. So this v square is going to be 4.2, and you take the square root of this, you get this as 2.049. Okay, so this v is 2.049. Guys, I'll not be deleting it from here. Okay, now I will see that what is the speed, what is its speed after it has rebounded from the cushion. Okay, so we shall find the 80% of this speed. So just to keep it exact, we shall not be like deleting it from here. So I'll be multiplying this value times 0.8. okay, so when I multiply this with 0.8, that is the 80%, so I get this as 1.63. so now this is the speed. Now for the next case, now this is the case, now this becomes the initial speed. U is equal to 1.6395. okay, when it reaches, it covers the maximum distance it has to, so at that point V will be 0. okay, we have to find the distance, how much distance it covers before it stops. okay, and again you see the acceleration we have, that is going to be the same because the ball is same, the surface is same. So guys, we will apply that equation 2as equal to v squared, which is going to be 0, and minus u squared. So you must be able to get that distance that it covers before it stops.